Good evening, students. Today we'll continue with the next question from whole concept exercise 5b. So in this numericals, we have completed up to 11. Now 12th one, let us see. They are asking calculate the weight or mass of an atom of oxygen, only one atom of hydrogen, molecule of ammonia, 10 power 22 atoms carbon, and the molecule of oxygen 0.25 gram atom of calcium. So if you want to solve the first question, so let us write like this. We know that Avogadro number 6.023 into 10 to the power of 23 atoms of oxygen. 23 atoms of oxygen. So what will be the mass of that? Nothing but 16 grams. So it's atomic mass, gram atomic mass. So here we have 6.023 into 10 power 23 atoms. They are asking what is the mass of one atom of oxygen or one oxygen atom. Take it as x. Now you know the method, cross multiply. What you get? 6.023 into 10 to the power of 23x is equal to 16. Therefore x is equal to 16 by 6.023 into 10 to the power of 23. So in the denominator, 10 to the power of 23 comes to the numerator as 10 to the power of minus 23. So we can write like this, 16 by 6.023 into 10 to the power of minus 23 grams. On calculating this, we get 2.657 into 10 to the power of minus 23 grams. So mass of one oxygen atom, we got the answer. Hope you have understood this. Now let us move to the second one. What is the mass of an atom of hydrogen? So only one atom of hydrogen. Hope you have copied this. Second one. One atom of hydrogen. So we know that if you take 6.023 into 10 to the power of 23 hydrogen atoms is equivalent to 1 gram. That already we know atomic mass. They are asking only one atom. So let us take one hydrogen atom. The mass is considered to be x gram. Cross multiply this. We get 6.023 into 10 to the power of 23 x is equal to 1. X is equal to 1 by 6.023 into 10 to the power of 23. Hope you have understood up to this. Now denominator 10 to the power of plus 23, when it comes to numerator becomes 10 to the power of minus 23. Therefore 1 by 6.023 into 10 to the power of minus 23 grams. Now for convenience, I have already calculated what is 1 by 6.023. Nothing but the total thing will become 1.66 into 10 to the power of minus 24 grams. Hope you have understood the method. Apply the same thing and find out for NH3. You know for ammonia what is the molecular mass? N is equal to 14. And here H3 you have, therefore it will be equivalent to 3. We can calculate it as 17 grams. So if you take Avogadro number, you have 17 grams and they are asking you to calculate for one molecule of ammonia. Let us solve that. Take your time and complete this. Hope you have copied this. Third one, we have calculated the molecular mass of ammonia. So therefore we can write like this, 6.023 into 10 to the power of 23 ammonia molecules. 23 ammonia molecules has a mass of 17 grams. Now they are asking only one molecule. Let us write like this. One ammonia molecule mass can be considered as x gram. You know the method, cross multiply. 6.023 into 10 to the power of 23x is equal to 17. Now take x, nothing but 17 by 6.023 into, here you know that it is 10 to the power of minus 23 grams. Now calculate this, take your time. Hope you got 2.823. So X value you got. That means mass of one ammonia molecule is 2.823 into 10 to the power of minus 23 grams. Hope you have understood this. Now take your time to calculate DEF and I'll give you the solutions. Now question number 20. Let us continue. Hope you have tried to solve this applying the same formula. 10 to the power of 22 atoms of carbon, they are asking the mass here. So you already know that 6.023 into 10 to the power of 23 atoms of carbon, that is Avogadro number, will be equivalent to 1 carbon is nothing but 12 grams. So we know this. They are asking 10 to the power of 22 carbon atoms. 22 carbon atoms. What will be the mass of that? Take it as X. Cross multiply and calculate this. So we know that 6.023 into 10 to the power of 23x is equal to 12 into 10 to the power of 22. Now take x and send this to other side. This is in the denominator 6.023 into 10 to the power of 23. So this can be easily cancelled out. It comes to the numerator becomes 10 to the power of minus 23. And here we need to just calculate 1 by 6.023. So if you are taking the approximate value, it will be nearly equivalent to 2. But if you write the exact value, 12 by 6.023 already I have calculated. So you can take it as nearly 2 into 10 to the power of minus 1 gram. Hope you have understood this. If you want to write it, you can also write it as 0.2 grams. Now in this condition, you can take it as 10 to the power of 22 atoms of carbon will be equivalent to 0.2 grams. So I am writing the answer for your convenience. So here we can just write it as 0.2 grams. Next one. One molecule of oxygen, what will be the mass they are asking? So let us calculate E. Make a note of this. Now if you consider E, that is nothing but oxygen, they are asking Avogadro number. So one molecule they say, so one molecule is nothing but O2. So we can take like this, 6.023 into 10 to the power of 23 oxygen molecules. What will be the mass of this? That is nothing but 32 grams. Now they say what will be the mass of one molecule. Take it as X, cross multiply. We get like this, 6.023 into 10 to the power of 23x is equal to 32. X is equal to 32 by 6.023 into 10 to the power of 23. This later we can write it as 10 to the power of minus 23. So calculate 32 by 6.023. I have already done for that. So we get 5.314 into 10 to the power of minus 23 grams. So make a note of this. It's very simple. Here it says that one molecule of oxygen, that is O2, has a mass of 5.314 into 10 to the power of minus 23 grams. So I will write the answer here, 5.314 into 10 to the power of minus 23 grams. The last one, 0.25 gram atom of calcium. So make a note of this. What is meant by gram atom? Is nothing but 1 mole of any substance. We can write it as gram atomic mass. For calcium, you know, it is 40 grams. So therefore we can write like this. First one, that is, we can take like this. 1 mole can be considered to be gram atom. So here, that is for calcium, mass is equal to 40 grams. So we can write like this. 1 gram atom of calcium can be 40 grams. Now they are asking 0.25. So we can write like this. 0.25 gram atom of calcium, take it as X, cross multiply. So X is equal to 40 into 0.25. See, 0.25 you can also take it as 1 by 4, so easy for you, it's 10. So we can take it as 10 grams. Hope you have understood this. 1 mole is considered to be the gram atom of any substance. So here it is equivalent to 40. Accordingly, we have calculated that, and X we got it as 10 grams. Hope you have understood this. So with this we have completed question number 12. Let us solve question number 13. Now try to solve question number 13 here. They have asked here, calculate mass of 0.1 mole for each of the following compounds, and here magnesium they have taken. See, in the bracket you are also having the atomic mass, and H2 I have written 18, the molecular mass of water. Now how to calculate that? For the first one, that is calcium carbonate, you try to find out the molecular mass. First and foremost thing, calcium atomic mass 40, carbon you have 12, and O3 you know that it is 16 into 3, 48. So here we have like this 8, 10. So we get 100 grams. So the molecular mass or 1 mole of calcium carbonate has a mass of 100 grams. Let us write like this. 1 mole calcium carbonate has a mass of 100 grams. So 0.1 mole, take it as X. See, you can do like this, or directly you can cancel. 1 mole is 100, 0.1 is nothing but divided by 10, like that also you can calculate. So stepwise, if you take X is equal to 100 into 0.1, nothing but 10 grams. Hope you have understood this. First one, calcium carbonate, if you calculate the mass of 0.1 mole is equal to 10 grams. Now second one, sodium sulfate decahydrate. So straight away you can calculate the molecular mass of Na2SO4 dot 10H2O. So here we can take like this. Sodium atomic mass is 23, so we write like this, 23 into 2, 46. Next sulfur you got 32. Oxygen you have 16 into 4, we get 64. And finally 10 into H2O, you know that one water molecule has 18, therefore 10 into 18, we can write it as 180. So find it out, we have 12, then 10, 18, 19, 22. So we get 322 grams. So the molecular mass of sodium sulfate decahydrate is nothing but 322 grams. So we can write like this. 1 mole Na2SO4 dot 10H2O is nothing but 322 grams. If you take 0.1, take it as X. Now X will become 322 into 0.1, so we have 32.2 grams. So 0.1 mole of sodium sulfate decahydrate will be equivalent to 32.2 grams. Hope you have understood this. I am writing the answers adjacent to this. You can calculate calcium chloride and magnesium by applying the same method. Make it fast. You can calculate in less than 1 minute. First method, identify the molecular mass of calcium chloride. Ca we have 40, chlorine 35.5, into 2 we have 71. So we get 111 grams. So we can write like this. 1 mole calcium chloride has a mass of 111 gram. Therefore 0.1 mole, take it as X. So X is equal to 111 into 0.1, nothing but 11.1 gram. Hope you have understood this. Mass of 0.1 mole of calcium chloride is nothing but 11.1 gram. Now the last one, what is the mass of 0.1 mole of magnesium atom? So here it is very simple. Straight away you can take magnesium, they have mentioned it as 24. So we can write like this. 1 mole of magnesium atoms has mass of 24 grams. 0.1 mole magnesium atoms, take it as X, cross multiply, X is equal to 24 into 0.1, nothing but 2.4 grams. So we can write like this. The mass of 0.1 mole of magnesium is 2.4 grams. So with this we have completed the solution of question number 13. Let us move to question number 14. Now let us solve question number 14 here. They have given calculate number of oxygen atoms in 0.1 mole of sodium carbonate decahydrate. Next one is they are asking you to find out gram atoms in 4.6 grams of sodium. Next one is how many moles are there in 12 grams of oxygen gas. One by one let us see. Here they have mentioned for 1 mole, if you consider that 1 mole of Na2CO3 dot 10 H2O, how many oxygen atoms are present? See, Avogadro number, you know, Avogadro number into number of atoms, that is atomicity. So you know this. Now for this we can identify here. So we have 3 oxygens and here 10. So totally atomicity will be 13 atoms. Oxygen atoms, how many are there here? We have 13 atoms, and Avogadro number, you know that it is 6.023 into 10 to the power of 23. So we can write like this: 1 mole of sodium carbonate decahydrate has this many number of oxygen. Now the question is, what will be the number of oxygen atoms in 0.1 mole? Let us write like this: 0.1 mole, take it as x, cross multiply. So what you get? You get x is equal to 6.023 into 10 to the power of 23 into 13 into 0.1. Now the whole thing 7.828, already I have calculated this. 7.828 into 10 to the power of 23 atoms of oxygen. So we can write like this. So x can be 7.828 into 10 to the power of 23 atoms of oxygen. So hope you have understood. Now question number 14b. So what is given? Calculate the number of gram atoms. They have just asked you to find out gram atoms from 4.6 gram of sodium. So we know that if you consider 23 grams of sodium, this is equivalent to 1 gram atom. Now they are asking you what will be the gram atoms for 4.6 grams of sodium. Cross multiply, you get 23x is equal to 4.6. Now x is equal to 4.6 by 23. So this is nothing but number of gram atoms. So calculate this. Hope you have got 0.2 gram atoms. So very simple. If you take 23 grams, you have 1 gram atom means 4.6 grams will have only 0.2 gram atoms. Now question number 14c, moles in 12 gram oxygen gas. So they have mentioned oxygen gas nothing but O2, and O2 will have, so 16 into 2 nothing but 32 grams. Hope you have understood this. It's not atom, it's molecule, gaseous molecule. So we know that 1 mole of oxygen gas has a mass of 32 grams. Now they are asking what will be the number of moles in 12 grams. So let us take it as x moles. Cross multiply, what you get? 32x is equal to, so we got 12. What is x? 12 by 32. So you can take 4 3s and 8. So we have 3 by 8 moles. If you still calculate this, 0.360 740. So we have 8 5s. So 0.375 moles of oxygen gas. Hope you have understood this. So copy the solution. Next, let us move to question number 15. Now question number 15, what mass of calcium has same number of atoms present in 3.2 grams of sulfur. So to understand the question, let us divide this into two parts. Number one for sulfur and second one is for calcium. So in this question they have mentioned 3.2 grams of sulfur. So this, let us see what will be the number of atoms present here. First let us calculate what will be the number of atoms. So take number of atoms as X atoms, and we know that Avogadro number or gram molecular mass, 32 grams of sulfur will have 6.023 into 10 to the power of 23 atoms. First we have to see for this particular mass how many atoms will come, and for that same atoms what will be the mass of calcium. That is the question. So 3.2 grams is X. On cross multiplication what we get? We get 32x is equal to 6.023 into 10 to the power of 23 into 3.2. Therefore x is equal to this value by 32. So we know this 3.21 and this 10 times. So we can just cancel this. 10 to the power of 23 by 10 will become 6.023 into 10 to the power of 22 atoms of sulfur. So we got the mass here. From that mass we calculated how many number of atoms of sulfur are there. Now the question is, you should have same number of atoms of calcium. So what are those? 6.023 into 10 to the power of 22. So we know this, nothing but 1 mole Avogadro number 6.023 into 10 to the power of 23 atoms of calcium has a mass of how much here? 40 grams. So this we know. Now what will be the number of atoms here? Same number of atoms to that of sulfur. What is that? 6.023 into 10 to the power of 22 atoms. Find out what will be the mass of this now. They are asking that only. What will be the mass of calcium? Now cross multiply, what we get? 6.023 into 10 to the power of 23x is nothing but 40 into 6.023 into 10 to the power of 22. I have just multiplied this. 40 into this is equal to x into Avogadro number. Now to find out x, 40 into 6.023 into 10 to the power of 22 divided by 6.023 into 10 to the power of 23. Now cancel this. 6.023 gets cancelled out. Now 10 to the power of 22. Can we write like this? Easily we can mention into 10. Is it right? 10 to the power of 23 can be written like this. Cancel these two. Now what you get? 40 by 10. Cancel 0. Therefore x is equal to 4 grams. Now we can say that 4 grams of calcium contains 6.023 into 10 to the power of 22 atoms, which is same as that of sulfur. So therefore take 4 grams of calcium, take 3.2 grams of sulfur, both will have same number of atoms, that is nothing but 6.023 into 10 power 22. So make a note of the solution and we'll move to question number 16.